Okay, now let's look at example 2, this one. Okay. So find all the values of x that satisfy x plus 8 is smaller than 10, or x minus 2 is greater than 2. Express the solutions graphically. So we have two inequalities to solve here, right? So the first one, x plus 8 is smaller than 10. Okay. We know that if we add or subtract any real number to or from both sides of the inequality, the sign doesn't change, right? So if we subtract 8 from both sides of the inequality, the sign doesn't change. So x plus 8 minus 8. And the right-hand side will be 10 minus 8, right? And the sign is the same. So plus 8 minus 8, this will become 0. So on the left-hand side, only x is left. So x is smaller than 2. So that's the solution to the first inequality. Second inequality, x minus 5 is greater than 2. Now, if we add positive 5 to both sides of the inequality, the sign doesn't change. Right? Because, like I said multiple times in class, the only scenario where the sign of an inequality changes is when you multiply or divide a negative number to both sides of the inequality. In any other scenario, the sign doesn't change, okay? So now we're adding positive 5 to both sides of the inequality. The sign stays the same. So x minus 5 plus 5, 2 plus 5. Minus 5 plus 5, this becomes 0, right? So the answer is x is greater than 2 plus 5 is 7. Okay. So we got our two answers here. Okay. Here, we need to pay attention to the question, what the question is asking. In this question, it says or. I think I've mentioned this in class. When the question is asking you something or something, that means either of the solution is correct. Right? So that means my solution doesn't need to satisfy both of the inequalities. As long as it satisfies one of the inequalities, is a correct solution. So if we draw the solutions on the real number line, okay. So first of all, we need to find the boundary points, right? So for the first inequality, we know that it's x smaller than 2. So the first boundary point is 2. And because there's no equal sign here, it's strictly smaller than, there's no equal sign. We use a small circle, right? So here at 2, at the point 2, we draw a small circle, right? And because the inequality is x is smaller than 2, so we draw this, right? Because this arrow indicates that I'm including all the real numbers that are smaller than 2, but not equal to 2. Okay, so this is what it means. This graph, it means I'm including all the solutions, all the real numbers. That are smaller than 2. but not equal to 2. And with the same logic, the other solution for the inequality is x is greater than 7, right? So the boundary point is 7. And because this one also doesn't have an equal sign, it doesn't have the equal sign, it's strictly greater than, right? We also use a small circle to indicate that the solutions don't include 7. So we draw a small circle here, and then we draw this, right? And this means I'm including all the real numbers greater than 7, but not equal to 7. Okay. And here is where most of the mistakes happen. Okay. So because the question says or, okay, because the question says or, the solution, the solution to this question, if you draw the solution on the real number line, it should be this. That means any number, any real number that is in this part or in this part satisfies these two inequalities. Okay, so let's say, for example, 0. 0 is smaller than 2. So 0 satisfies the first inequality, but 0 doesn't satisfy the second inequality. But it doesn't matter here. It doesn't matter here because the question says or. That means as long as a real number satisfies one of these two inequalities, it counts as a solution to this inequality system. Okay, so this is or. You need to remember that. Okay, so if the question says or, that means solutions to this inequality and solution to this inequality, they both count as the solution to these two inequalities. Okay, whereas if the question says and, that's a different story. Okay, so we'll see that in the next example. Okay, so the question says, find all the values of x that satisfy x plus 8 is smaller than 10. So the inequalities are the same, okay? And x minus 5 is greater than 2. Find all the values of x that satisfies both. We know that the solution to the first inequality, so this one, the solution is x is smaller than 2. For this one, the solution is x is greater than 7. Is there any real number that can satisfy both inequalities? No, because there's no real number that is smaller than 2 and greater than 7 at the same time, right? So if you draw this on a real number line, so this is 2, right? So this is smaller than 2, and this is greater than 7, right? Now we're asking for the overlap part of these two solutions, which is here. But you can see there's no overlapping part, right? Because there's no real number that can satisfy both inequalities at the same time. There's no real number that is smaller than 2 and bigger than 7 at the same time. So for number 2, for this one, the answer is there's no solution for x. Such x doesn't exist. So here, You can say such x do not or does not exist. You can write D and E. It stands for does not exist. Okay. Or you can say no solutions for x. Like either way works. Okay. So this example, in this example, we need to learn the difference between or and and. Okay, because like the difference of the wording, okay, can result in like very, very different solution. Okay, so this is a very important example. Okay. Okay, so let's look at class practice. Okay, so number one, it says solve and graph the solution set. X minus 2 over 3 is greater than x over 2 minus 3. Okay, so like I said in class, solving for inequalities is very similar to solving for equations. Okay, most of the properties still hold for inequalities. The only thing we need to remember is to change the sign when we multiply or divide a negative number to both sides of the inequality. Okay. Otherwise, all the properties, all the rules are the same. Okay. So let's just see what it means. So when we see this question, when we look at this inequality, my first instinct tells me to multiply 6 to both sides of the inequality because I want to get rid of the denominator of the fraction, right? So on the left-hand side, I have a 3. On the right-hand side, I have a 2. So in order to get rid of the denominators, I need to multiply their least common multiple to both sides of the inequality in order to get rid of the denominators, right? So let's do this step by step. So the first step, I'm going to multiply 6 to both sides. Okay, so 6 times x minus 2 over 3. And the other side, 6 times here, x over 2 minus 3. This is like you need to put brackets, okay, because this is not one term. These are two terms, okay. So you need to put them in a bracket. X over 2 minus 3, right? And because in this step, we multiplied a positive number to both sides of the equation, the sign doesn't change. I repeat it one more time because this is extremely important. The sign only changes. The sign of an inequality only changes when we multiply or divide a negative number to both sides of the inequality. Okay, addition, subtraction, multiplication, and division. For positive numbers, the sign doesn't change. Okay, so the sign stays the same. This is very, very important. Okay. Now we know what to do, right? So let me just put a bracket here as well to make sure that we don't make any mistakes. So 6 times the whole equation, this becomes 1, this becomes 2. So 2x minus 2 is greater than, okay, so here we use the distributive property, right? So we need to multiply 2 by this, and then 6. We need to multiply 6 by x over 2 and 6 by 3, right? So here, 6 times x over 2, that's 3x, right? Minus 6 times 3, that's 18, right? So Now we solve this inequality. Okay, 2 times x minus 2. Here we also use distributive property. Okay. We need to multiply 2 by x and to 2, right? So 2x minus 2 times 2, that's 4, right? Greater than 3x minus 18. Okay, so now, like how we solve for equations, we move all the unknowns to one side and we move all the numbers to the other side. Okay, so here, in order to avoid any negative unknown, I decided to move 2x to this side, because this way I don't need to deal with negative unknowns, right? Because if you move 3x to the left side, that will be 2x minus 3x will be which will be minus x. Then you need to deal with a negative number after, right? So I don't want that. I don't want to make any mistakes. So let's just use the easier way. Okay. So so on the right hand side, it will be 3x minus 2x, right? And the sign doesn't change. And then now we move minus 18 to the left side. So we move this. We need to move the whole thing. Okay, minus 18 to the left side, which will be positive 18, right? So minus 4 plus 18. Okay. Now we just organize this inequality a little bit. By tradition, we usually put the unknowns on the left side and the numbers on the right side. So we need to, so we just flip it, right? So this will be 18 minus 4, that's 14, right? And x. And this will be x smaller than 14. Just let me check if my answer is right. Yeah, that's right. Okay. So this is the solution. This is the solution to this inequality. Okay, and now we need to graph it. First of all, we need to find the boundary point, right, which is 14. So we found the boundary point here, this one. Now we need to see whether there is the equal sign. So whether the sign is this or this, because these two different signs indicate different things, right? For this strictly smaller than, we use a circle, small circle on the point. Whereas if it's smaller than or equal to sign, we use a solid point. Okay, so here, x is strictly smaller than 14, and that means we should use a small circle. Here, small circle, okay? And then we draw this. To indicate that my solution includes all the real numbers that are smaller than 14, but not equal to 14. Okay, so you need to understand the meaning of the graph. This arrow, so this whole graph, this means the solution includes all the real numbers that are smaller than 14, but not equal to 14. Okay, because it's a small circle here. That indicates that my solution doesn't include 14. Okay, so this is this question. This is how we solve this kind of questions. Okay, let's look at number 2. Find all the values of x, such as 5 minus 2x is greater than or equal to. See, this is, so this has an equal sign, okay? is greater than or equal to 1, and 4 minus 3x is smaller than 7. Express the solutions graphically. So here, there are a few things that we need to pay attention to. Okay, so first, here, this is greater than or equal to, which means when we draw the solution on the row number line, we need to use a solid point to indicate the boundary points is part of the solution. Okay, also it's and. The question is and, which means my solution needs to satisfy both the inequalities. Okay, so let's just see what the solutions are. First one, 5 minus 2x is greater than or equal to 1. So here I want to show you what it means by flipping the sign when we divide a negative number to both sides of the inequality. Okay, I want to show you how we do that. Okay, so 5 minus 2x is greater than or equal to 1. We should be able to solve this by now, right? Because we have learned all the techniques that we need to solve this kind of questions. So first, we subtract 5 from both sides. Okay, so 5 minus 2x and minus 5 greater than or equal to 1 minus 5. This is the first step, right? And 5 minus 5, that becomes 0. So only minus 2x is left on the left-hand side. So minus 2x, right? Greater than or equal to 1 minus 5, that's negative 4, right? Now we have a negative coefficient of the unknown on the left-hand side, right? We want to have the unknown with the coefficient of 1, right? We want to know x. We want to know the solution for x, not minus 2x, right? So we need to divide it. So we need to divide negative 2 for both sides of the inequality, right? So here, minus 2x, I will write it here. I'll write it here so it doesn't affect our graph later on. Okay. So minus 2x, I need to divide minus 2x by minus 2 to get rid of the negative coefficient, right? And for the right-hand side, I also need to divide minus 4 by negative 2, right? Here, see, we divided a negative number, negative 2, on both sides of the inequality, right? We divided a negative number here, a negative number here. This is when we need to change the sign, okay? This is when we need to flip the sign. Originally, the sign is greater than or equal to. Now we need to flip it to make it smaller than or equal to. This is what I meant by flipping the sign when we multiply or divide a negative number to both sides of the inequality. Okay, so from this step to this step is very, very important. Okay, it's very important. Okay, so now it's getting easy. Minus 2x divided by minus 2, that's x, right? And the sign doesn't change. Negative 4 over negative 2, that's 2, right? So first part of the solution is x smaller than or equal to 2. So this is the solution for the first inequality. The solution for the second inequality Let's try to solve it. Okay. So here, it's this one. I'm talking about this one. Okay. So 4 minus 3x smaller than 7. So we need to subtract 4 from both sides of the inequality, right? We have done this multiple times. Right? 4 and 4 cancels out. Okay. And only 3x is left on the left-hand side. And 7 minus 4, that's 3, right? Here, this is the same scenario. Okay, we have a minus, we have a negative coefficient of the unknown. We need to make sure, we need to get rid of the negative coefficient by dividing the negative number. Okay, so here, I will write it here. So minus 3x over minus 3. And the other side is 3 over, oh, sorry, did I say minus? Sorry, I meant minus 3x over minus 3. And the other side is 3 over minus 3. Okay. Here, we divided a negative number to both sides of the inequality. This is when we need to flip the sign. Okay, so originally we have a smaller sign, right? Now we need to flip it to make it greater than. So from this step to this step, it's also very important. Okay, you need to know when to flip the sign. And now it's easy. Minus 3x over 3, minus 3, that's x, right? So x is greater than 3 minus 3 over minus 3, that's minus 1, right? So this is the second part of the solution. Okay. So now, because the question says and here, the question says and here, right? That means our solutions must satisfy both of the inequalities, which means we're looking for some real numbers that are smaller than or equal to 2, and at the same time, greater than minus 1. Okay, so you will understand it after I draw the solution on the graph. Okay, so first, like how do we draw the solution on the graph? First, we need to find the boundary points, right? Which is 2 and minus 1. Okay, 2 and minus 1. So 2 here, minus 1 here, right? The first part of the solution says x is smaller than or equal to 2. That means we need to use a solid point on point 2 to indicate that number 2 is included in our solution. So here, we draw a solid point here. Smaller than or equal to 2. Okay. And the second part of the solution says x is greater than minus 1. So here, there's no equal sign, right? X is strictly greater than minus 1. That means we need to use a small circle here. Small circle here. Okay. See, here we have an overlapping part here, right? This means for these two inequalities, there are solutions because graphically, like we can see, there is some kind of overlap, right? So this is the solution. Okay, this is a solution. And when we have this kind of inequality system, like we call this inequality system, okay, when we have more than one inequality, we tend to try to write the solutions in one inequality. Okay, so x is smaller than 2, smaller than or equal to 2, and x is greater than -1. We can write it as, so here, x is greater than -1 and smaller than or equal to 2. Okay, so you can write a solution like this. So this is the numeric solution, and this is the graphic solution. Okay, so this is how we solve this kind of questions. Okay, and for the word problems, I will make another video. Okay, because I don't want the videos to be too long, and I don't want you to lose interest. So I will see you in the next video.